At least, not in the way we currently understand it. Most of the large-scale structures observed by the Webb telescope in the early universe don't align with this model either. Cosmic voids, in particular, are often too symmetrical or too common to be dismissed as statistical anomalies. What's more, strange phenomena occur within these voids. Light traveling through them is distorted and redshifted in ways that differ from the rest of the universe. Even more puzzling, galaxies located in or near these voids seem to move at such high velocities that the standard cosmological model can't adequately explain their motion. These vast, enigmatic voids have already been described as active anomalies in our understanding of the cosmos. One possible alternative explanation is the Timescape model. To explore this further, we need to consider how time behaves around voids. Instead of expanding uniformly across all regions of space, voids are demonstrably expanding faster than the denser regions around them. To an observer situated within a cosmic void, the universe might seem to be expanding at an accelerated rate. However, this perception could be an illusion caused by distortions in time. In such a scenario, what we currently describe as dark energy might actually be a result of scientific misinterpretation and observational error. If the Milky Way is indeed located within the KBC supervoid, then we occupy exactly the kind of position that would produce this optical distortion. The structure of time itself could vary depending on the distribution of matter, the cosmic structures, and whether the observer is in a dense or sparse region of the universe. This raises deeper questions. Can we meaningfully determine the age of the universe under these conditions? Does the universe even have an age in the traditional sense? And ultimately, how crucial is this concept of age to our scientific understanding? Time, undoubtedly, remains one of the most perplexing challenges in science. Albert Einstein once said, "Time and space are not conditions in which we live, but modes in which we think." Time is one of the most familiar concepts in our daily lives, yet it remains one of the most puzzling in all of physics. Its mysterious nature has also made it a central topic in philosophy for centuries. We tend to experience time as linear, a continuous stream of moments moving from the present into the future. What has already happened is regarded as the past. But when we try to define time in objective, scientific terms, things quickly become complicated. In physics, there isn't just one universal concept of time. Different definitions exist, depending on the context, and sometimes, these ideas even contradict one another. In classical Newtonian physics, for example, time was considered absolute. Newton believed that time flowed uniformly throughout the universe, independent of location or movement, a constant backdrop against which all events occurred. Albert Einstein challenged this idea with his theory of relativity, demonstrating that time is not absolute but relative. Time flows differently depending on factors like gravity and speed. The stronger the gravitational field or the faster an object moves, the more slowly time passes relative to an outside observer. While this effect is minimal on Earth and within our local cosmic neighborhood, it has been confirmed through precise measurements using atomic clocks on airplanes and satellites. Einstein famously remarked, "The distinction between past, present and future is only an illusion, albeit a persistent one." This statement highlights a deeper philosophical issue. Time may not be a fundamental part of reality at all, but rather an illusion, an artifact of human consciousness that emerges when we view space-time from a limited perspective. Modern research into consciousness suggests that humans may actually project reality, including time and space, from within our own consciousness. If this theory holds, it would support Albert Einstein's assertion that time and space are merely modes of thought, rather than inherent realities. In quantum physics, time is not clearly defined. Many equations function without reference to time, as though it is irrelevant. Quanta, for example, do not experience time and can exist across multiple times and places simultaneously, suggesting that the dimensions of time and space may not exist at all, or at least not as fixed or reliable entities. In thermodynamics, time manifests as entropy, the so-called arrow of time, which points from order to disorder. However, even this arrow is not a fundamental or absolute force, it merely represents a probability. When we measure the universe, such as calculating its age or the rate of its expansion, we tend to assume time passes uniformly and synchronously across all regions. Yet phenomena like time dilation and theories like timescape cosmology suggest this assumption is flawed. Time may not be universal, it could vary from one region to another. This brings up the question of whether an objective, universal time exists, or whether each region of the universe has its own distinct cosmic time. Could the strange interaction between Voyager 1 and an unknown interstellar force be something we still don't understand, or is it something far more unsettling, proof that we are not alone? For years, scientists have speculated about the existence of extraterrestrial life, yet all attempts to detect intelligent signals from space have led to no conclusive evidence. But what if we've been looking in the wrong places? What if the answer has been out there all along, and Voyager 1 unknowingly discovered it? Some researchers worry that the signal could be an attempt at communication, an unknown entity responding to Voyager 1's presence. If so, what is it trying to say? A greeting? A warning? Or something more cryptic? Others propose a darker theory. What if Voyager 1 has entered a region of space that was never meant to be explored? What if the reason we've never encountered other civilizations is because they have intentionally stayed hidden? And what if, by venturing beyond our solar system, we've inadvertently revealed ourselves to something that was never supposed to find us? NASA now faces an unprecedented enigma. The signals keep coming, but their true meaning remains a mystery. Could this be a scientific anomaly, an unexplored natural force at play, or has humanity just made its first, perhaps most perilous, contact with something beyond our understanding? The invisible presence, at first, it seemed impossible. Voyager 1 had already passed beyond the reach of any known celestial bodies, drifting through the silent, empty expanse between the stars. It should have been following a predictable, linear path, as physics would suggest. But the data told a different story. Something was out there, something enormous, something powerful enough to alter its course. Yet when NASA examined the surrounding space, they found nothing, no planets, no asteroids, no stars. Whatever this force was, it wasn't emitting any detectable light or radiation. It was completely invisible to traditional observation methods, but its gravitational influence was undeniable. This narrowed down the possibilities to just a few. One theory proposed that Voyager 1 had come across a rogue planet, a massive world drifting through the galaxy without being bound to any star. While rare, such planets do exist, having been ejected from their original solar systems to wander the vastness of interstellar space. Yet, even the darkest of planets can be spotted by the way they block the light of distant stars. But this object remained completely invisible. The next theory was even more unsettling, a dark matter object. Scientists believe that dark matter accounts for most of the universe's mass, yet it cannot be directly observed. It neither emits light, reflects radiation, nor interacts with ordinary matter in a way that can be detected. But if Voyager 1 had crossed paths with a dense clump of dark matter, could it have influenced the spacecraft's movement in ways we don't yet comprehend? Then, an even more disturbing possibility arose, a primordial black hole. Unlike the supermassive black holes found at the centers of galaxies, primordial black holes are thought to be ancient, tiny remnants from the dawn of the universe itself. Although small, these objects can possess remarkable density, with gravity strong enough to affect the trajectory of nearby objects. If Voyager 1 had come too close to such an object, it might explain the unusual shifts in its path. But there remained one final, unnerving possibility. What if this wasn't a natural event at all? What if Voyager 1 had encountered something entirely beyond our scientific comprehension, something artificial, perhaps even alive? Then came the most unsettling piece of evidence. As engineers reviewed Voyager 1's latest data, one set of readings stood out. At a specific moment, the spacecraft had altered its course slightly, as though influenced by something nearby. This change wasn't part of any planned maneuver. It wasn't a malfunction. The signal didn't follow any known format. Instead of the usual structured data, it was a mix of zeros and a random number, 377. There was no context, no explanation, just an out-of-place number floating in the middle of a data stream. The good news was that the rest of the spacecraft seemed unaffected. There were no emergency alerts or automatic shutdowns. Voyager 1 wasn't in any danger, it was simply confused. But why? After months of investigation, scientists discovered the issue was with the AACS. Even stranger, the part of the computer that was sending the data had actually stopped working years ago. For some unknown reason, the spacecraft had begun routing its communication through a malfunctioning system that hadn't been active in years. The result was nonsensical, corrupted data.